All right. So we are looking for K. Now let's look at the following. K, it's not the value that we substitute to get the last term. Unlike the previous question here. Because I think people might confuse it here. So here, K is on the top, which is the value that we substitute to get the last term. Here, K is Tn basically. This K that you're looking for, it is the general term of this sigma notation. K is the general term of this sigma notation. Now, we know how to deal with this one here. This one I think we can do. Because we can say this one here, it's a sigma notation. And then if it's a sigma notation, we have R is 5. So we're going to sub 5 so that we can get the first term. So this is how I do it. I will say which we have 3 multiplied by 5 minus 4. This is going to give me the first term. Plus, then I will say which I have 3 multiplied by 6 minus 4, which is going to give me the second term. Plus, this is going to give me the third term, which is going to be 3 multiplied by 7 minus 4. Plus 1, 2, 3. And then after that, I will say which it's 3 multiplied by 60 minus 4. This is the value. This is going to give me the last term. And then you said here what we get 11 again. Plus 14 plus 17 plus 1, 2, 3. And then here you said we get 176. You see, with magic, it avoids that thing which I can make a mistake of saying T6 because I simply substituted to say, okay, this one is term number 1, and then this one is going to be the last term. So I don't have to say this is term number 1. I will get it from the sequence. As soon as I have the sequence, then I will say, okay, this is term number 1, this is term number 2. Okay, since here this thing here it's linear, we said the first thing that we're going to check is arithmetic. Okay? So if we check arithmetic, we're going to have 3. Yeah? This one subtract this one, 3. Okay, sure. Then from here onwards, we can say which we have Sn, which is going to be given as n all over 2, A plus L. Now we need to know what is n. And how do we get our n? We get our n by saying top. What is written at the top? It's 16. So we have 60 minus 5 plus 1. And then what do you get after that? We get 56. Okay, so it means which we have 56 terms. So we'll come and say, okay, we have S56, which is going to be given as 56 all over 2. And then we have our first term, which is 11 plus 176. And then you get an answer here. First, what is the answer? 500. 5,236. Now, this is how you can think of this thing, man. Basically, here's what they are saying here. They are saying 5,236 is equaling to the sum of when P is equaling to 2 up until P is equaling to 5 is going to be equaling to K. So it looks something like this, man. We know the sum. Everyone. So remember here, they were giving us to say which this following sigma notation is going to be given by this thing here. So this one is exactly the same, man. The only thing that they did here was they make it long. They wanted the learner to use the sigma first to get the sum. I get this one because you know what is the value that you substitute to get the first term. You know the value that you substitute to get the last term. Then you can get the sum of this thing. Now here, also here, you can get, because you know what you're going to substitute, P is 2 again. Then you substitute P is 3. Then you substitute P is 4. Then you substitute P is what? It's 5. So let's check how best can we do this thing? First, I need to explain this. Suppose which Elena is given something like this. TK is going to be equaling to 2 multiplied by K plus 1, like this. And then they say to you, what is going to be TK when P is 1? What will you say? I'm saying here, I give you the following equation. TK is equaling to 2K plus 1. 2K plus 1. Okay, maybe let's do it this way so that everyone can understand. Let's start with K. Tell me when K is 1, what is going to be this thing here? What will you say? How would you do it? It's 3, ne? How did you get 3? You said T multiplied by 1 again, which is going to be 2 multiplied by 1 plus 1, which is going to be equal to what? 2, 3. So what does that mean? It means when k is 1, you are going to substitute everywhere you see k, you are going to put what? 1. Okay, let's try this then. What if I then say when p is 1, what do you do with that? Where's p? That's the question that you should ask. Right? Yeah, so when p is 1, what is going to be this equation? Tk is going to be equal to 2k plus 1. P doesn't affect this thing. Yeah, remember, you said what does the k says? It says everywhere we see k, we're going to put what? 1. So if I change k this side, I also need to change it on the right hand side. Now I give you p. You say p is irrelevant to this equation. I ask you what is going to be the new equation. The new equation is still going to be t is equal to 2k plus 1 because there is no p in that equation. So p doesn't have any effect on this equation. It's fine. Okay. Let's try something like this then. What if I say what is r? What will you say when I say when r is 1, what is going to be this equation? What will you say? Yeah, it doesn't matter. There's no r there, it doesn't affect. So this thing works this way. The reason why you have here, look at this. The reason why you have r here, you have r here and then you also have r here. It's not a mistake. So that you can substitute for r is 5, you substitute for r is 6, you substitute for r is what? It's 7. But if all of a sudden, Mina, I say to you, here there's r. I say to you, here there's r, but here there's p. These two things, they don't have any relation anymore. When r, you ask this question, when r is 5, what will be this thing? It will be 3p minus 4. When r is 6, what is this thing? It's 3p minus 4. When r is 7, what is this thing? It's 3p minus 4. Because here you have r, but here you have what? You have p. So it doesn't have any effect on it. Now that is said, let's try the following then. Look at this here. What are we going to do with this information? We're going to say when p is 2, what is this general term? I can remember how many values should we substitute here? They're not many here. We should substitute when p is 2. We should substitute when p is 3. We should substitute when p is 4. We should substitute when p is what? It's 5. All in all, we have 4 terms basically. So here's what you're supposed to do. You are supposed to say, let me erase this so that, like, I want us to be here so that we can see everything. So look at this here. You'll start by saying, let's start with p is 2. When p is 2, what is k? It's k. Okay? Plus, when p is 3, what is k? It's k. Plus, when p is 4, it's k. Okay? When p is 5, what is k? It's k. Yeah? Now remember, what does the sigma say? It says you add everything up. Okay? Now, if I add k plus k plus k plus k, what is it going to give me? It gives me 4k. So this whole thing here is equal to 4k. Yes. The what? The k, yeah, the k here. Remember what does the sigma say? It says we are going to substitute. This is the value that we substitute to get the first term. This is our first term. And then we do it consecutive. Which what is the number that follows 2? The number that follows 2 is what? It's 3. When p is 3, what is k? K is still k because p and k, they don't have any relation. When p is 4, what is this thing? It's still k. When p is 5, this thing is still what? K. And then from there onwards, you could have said this thing, what kind of a sequence it is, and then you said it's arithmetic, and then you calculated using that arithmetic sequence. But because there are few, I said to learners, if they give you a sigma and then they give you values that you can calculate, which it's like 10 times, don't use a formula, calculate those things. Say 2 plus 3 plus 4, and then you get which one is going to be your answer. I'm a formulas. You see here, you're supposed to calculate the sum of 56 terms. 56 terms, you can't add them up. There are many. That's when you use a formula. So how are you going to get your k given? Where's Rapello? Rapello. So you got the sum this side, and then you're going to say 4k is going to be 5, 2, 3, 6. You divide by 4, and then it says k is going to be, what is the answer? 1,300 and what? And 1300. 1309. So it's 09. Okay. Yeah, then that is going to be our K. So what should we take from this question, guys? Even if they can give you 4 sigma notations, it doesn't matter. Take sigma notation number 1, deal with it. Take sigma notation number 2, deal with it. And then when you deal with sigma notation, all of them, you deal with them exactly the same way. You expand. That's the rule. You expand from the value that they gave you here. If they gave you 5, you start with 5. Here they gave you P is 2, you start with 2. If it's let's say which they gave us 100 here, they said from RS5 is 100, you need a formula. If they said from 2 up until 7, add those things up, man. Is P is 2, is P is 3, is P is 4, P is 5, P is 6, P is 7, and then you're done. You add those things up. I stop here.